Awesome. Great to see everyone this morning. I'm very excited to be up here talking to you about what was probably like the worst 2 months of my life. That's actually not entirely true because it's absolutely terrifying. When Bridget and I started talking about doing this talk a few months ago, I was thinking like, oh yeah, this is gonna be great. This is exactly the type of talk that I want to hear. I think people get a kick out of this. And then as I started reviewing my Slack and pulling together screenshots of everything that went on, I started having anxiety attacks, reliving this moment, thinking, oh my God, I'm not gonna be able to do this. I'm gonna be bearing my soul to everyone here, and they're gonna be like, this guy's an idiot. And then I came yesterday and I was listening to all of our wonderful speakers yesterday, and I went home and I looked at my wife and I said, it's official, I'm a complete imposter. Because everything yesterday was amazing. Like, it was so great. So I sat on that all last night just thinking, like, do I call Bridget? Do I say I'm coming? I'm not coming. I'm sick. My kid's sick. I'll use her. Like, what are my options here? And when I woke up this morning, it dawned on me that this is actually quite perfect because all of the talkers yesterday, all of our speakers were talking about the complexity of the systems that we build out there, and how do we do blameless retros and all these wonderful things that make us better at doing our jobs. And that's what I get to share with you. I get to share an actual practical, case of this and what we learned from it. So a couple disclaimers before I start. First, this is not a talk about any specific technologies. I will be mentioning technologies, but it's not about them. It's not about what they do well or do poorly. I'm not advocating for them or against them. I'm not saying that you should use it or you shouldn't use it. Everyone picks the tools that they pick for their reasons, and that's great. But we do need to be able to talk about the actual specifics here, right? So I will be talking about those things. What this talk is, like I said, is just an analysis of a complex system and how it failed in ways that even to this day I don't fully understand, right? Mysteries of the universe type stuff, right? And I hope it's really just a learning opportunity for all of us. So quick little background before we get started so that you can understand the context in which this failure happened. For the last couple of years at Target, we've been building an internal application platform that we call TAP. We have a few principles on it, mainly that as an enterprise organization, we have a lot of legacy infrastructure that exists for reasons. And we can't just rip it all out and replace it with the shiny good and best of the day, right? We have to make it work. And the biggest thing that TAP's trying to solve is giving our developers across the entire organization the ability to effectively use that infrastructure to do their day-to-day jobs, right? So that's what TAP's trying to do is provide this unified experience for all of these things. So when we built TAP, we made a few opinions up front. There's two environments. There's prod and there's not prod. There's no stage, there's no UAT, et cetera, et cetera. There's just the two. You can create things inside of that, but that's all. We don't use virtualized networks. So every workload on TAP runs on our core network. So we don't have that layer of complexity from that side. We issue IP addressing through DHCP to those things. We have to deal with multiple data centers, multiple cloud providers, multiple endpoints, WAN, LAN, all sorts of stuff. And then we have multiple compute providers. So we run hundreds of Kubernetes clusters behind TAP. We run OpenStack installations. We run schedulers that talk to libvirt behind TAP. And our developers are completely transparent to any of that stuff, right? So that's the system that we're trying to build. From a workload perspective, then, because we want that the ability to move that workload around, that workload has to be self-contained. So every workload that we deploy out contains all of the capabilities that it needs to operate to do things like logs, metrics, talk to the platform to get config and secrets, et cetera. We run things like HashiCorp's console, HashiCorp's vault to provide some of these things because, well, I mean, who doesn't run HashiCorp, right? Like, these technologies are awesome. I've been using Consul since the 0.2 days, which was about, like, I don't know, a month after they released the project. And they're just very, very good at what they do. But we picked the tools, we picked each of the technologies in TAP to do one thing well, right? We don't want the Swiss Army knife that's going to do all the things, right? Like, pick the thing or build the thing to do one specific task, right? Very microservice-y in that sense, right? And it lets us pick the tools that fit our patterns the best and also have are the most resilient. So that's the context. That's where we're starting from. So what happened? Day 0 of many. So our whole problem started with a software-defined networking update, so an SDN update in one of our networking fabrics. So I mentioned earlier that we don't use virtualized networks. That's still true, but we still have to have things for broadcasting route information into the switch infrastructure. And that was what was getting updated. So this shouldn't be too big of a deal, right? But we're using Consul, right? And a Consul cluster works by every node inside of the cluster gossips information to other workloads. Specifically, it uses a toolkit, a library called SURF, which is based on SWIM, which stands for Scalable Weakly Consistent Infection Style Process Group Membership. And this is the only time that any of us should be deciding to put something with infection in the name into our prod systems. The way that SURF works is that intermittently, periodically, workloads ping each other, saying, hey, are you there, right? And if that workload comes back, then we think you're healthy, and we can tell the rest of the cluster that, hey, that node's healthy, right? In this way, we can the cluster works around network partitions or other things that can happen inside of a complex network. However, when things go wrong, and that workload, when one workload tries to ping another and it doesn't get an answer or a response, it doesn't immediately say, hey, that thing's gone, mark it unhealthy. Because we don't actually know who the unhealthy is in that case, right? So what SURF does is that workload then asks another neighbor. It asks his friend or two friends to also, hey, can you go check that workload as well, right? So then those workloads ping in, and then they can tell you if it's up or not, right? So we can figure out where's the partition, what's the part of the network that's actually offline, and all that type of stuff. What happened to us, though, and what started this whole thing, is that our SDN update didn't hard down the network. It didn't just fail. That would have been awesome. Had that happened, I wouldn't be standing here today for you. Instead, what it did is it made the network flap in and out. And when you're dealing with this kind of gossip system that's sending these probes around the network on periodics, and you're intermittently getting responses and not getting responses, you're basically getting a whole lot of messages in the cluster saying, that thing's here, that thing's not here, that thing's here, that thing's not here, right? And it goes on and on and on and on, and you eventually end up in this state that we got to. So our problem was that the cluster was flapping like tens of thousands of nodes in and out. And it was broadcasting all these messages about these nodes flapping out, so all the healthy nodes then had to process all the messages about these nodes flapping in and out, and that caused problems. It was at this point that we started looking through various console changelog messages, because we had been running a version, it had been running great, and why update when we don't need to update? Well, we missed the update then that was like, hey, if you're running a cluster of more than 10,000 nodes, you probably should be on this version. And we had blown way past that at this point. So first step was to maybe update some of those things, right? Kind of, retrospectively, we probably should have kept up to date more on those things. Okay, so where did this go from being like a minor annoyance to an oh crap moment, is because we have these isolated workloads, every workload in TAP is running a console agent. And because now we had this tsunami of messages coming into each one of these things talking about how the the cluster was flapping in and out, the CPU and memory requirements of this console agent started getting higher and higher because it needed to do more work. This is a problem when you're running something like Kubernetes behind the scenes because you have to allocate shared resources off your compute platform to these workloads. So as the console agents started asking, trying to do more things and using more CPU requirements, all the workloads on a Kubernetes worker started doing the same thing. Well, CPU and memory are finite, so when that happened, the Kubernetes worker then said, I can't do anymore, I'm unhealthy. Mainly because we were sucking so much CPU out of the Docker daemon that kubelet couldn't talk to Dockerd anymore, so it couldn't tell us the state of the node. So the node marked unhealthy, and in its brilliance, right, in order to keep our things up, Kubernetes says, oh, if that node is unhealthy, let's move all the workloads off of it. And so it takes all those workloads that are needing much more resources than they typically do, and move them to other nodes that were running a bunch of workloads that were using a bunch more resources than they normally needed. So that was great, right? Because that just caused more problems, because as these workloads terminated on one node, they had to say, hey, cluster, I'm leaving. And when they showed up on another node, they had to say, hey, cluster, I'm here. So we just started generating more load inside of cluster, and the more load, or inside of console, and the more load meant more problems, and we are off to the races now with a full-blown cascading failure, thundering herd, all the things. So what could we possibly do at this point? Well, first was we need to remove that affected network fabric, right? We need to get things out of there so that we can let the messages die down, and we need to get all the workloads inside of there move to healthy areas of our platform. So we got the team together. We did all that. The end. No? Right, okay. Yeah, you didn't follow. Obviously not, right? So day 0 to week 1. So moving the workloads off, that was actually something that we were able to tactically do within a couple hours of the problem starting. And we were able to kind of patch it up and keep it in what I want to call a stable, degraded state at that point. We knew things were bad, but we were able to keep them up mostly for developers to continue using, and it wasn't impacting any type of production systems at that time. Luckily, this problem all happened in our non-prod environment and not our prod one too. But we kept working on this and kept going at it. And one of the biggest things that we didn't have at the time is because of our confidence in some of the tools that we use. We had combined 15, 20 years of experience running console in production systems between engineers on our team. We failed to realize what insights and what telemetry we properly needed off that cluster to understand what was going on in this kind of thing. We knew we had the basics, right? We were watching the things that everyone watches, but at this point we were digging down and looking at console source code and looking at all the various hidden metrics that they don't talk about anywhere and plotting them on dashboards to see if we could figure out what is causing this degraded state as we go. This is never a graph that you ever want to see anywhere in an operational dashboard, right? Exponentially increasing with oscillations. Not going to be a good day. Not going to be a good week. So bad sign, right? So at this point, this is probably about the time where I had my first real good cry at about 2 a.m. Sitting at my kitchen table because I had just literally no idea how this could be happening for things. It turns out that there's another kind of intricate behavior inside of the console agent that if you don't go through something like this, you might not learn about. And that's that obviously when it's processing messages, you have to have a message queue inside of it, right? So new new messages from the cluster come in, the agent processes those messages off, and then also rebroadcasts those messages out to the cluster, right? So because it's gossiping, right? So if I hear that a node left, I got to go tell the rest of the cluster that the node left, and eventually the cluster converges to some state of here's who's healthy, here's who's in and who's not in. The thing is like most messaging queues, you can only hold so many messages inside of that queue. So when you're generating a whole bunch of them, you hit this limit. And the obvious thing to do from a development point of view is that when you hit the max, you just stop accepting messages into the queue. This is the exact wrong thing you want to have happen when you're having a thundering herd problem, because new messages are more important than old messages. More specifically, like join messages are even more important than leave messages. If you told me that you're here, then I don't need to process or rebroadcast that you weren't here. This is not what console was doing for us at this time, right? So as we were churning these workloads and pushing them through, we were rebroadcasting these effectively invalid states. And so even though we had moved workloads out of our affected network fabric, we never could get the cluster to forget that those workloads weren't there anymore. Because the messages about them leaving and joining, that giant problem, was continuously replicating throughout the cluster. It was being rebroadcast by nodes because of this problem, right? Because the agents couldn't churn through them. The message loads were just too big. So we had basically what we started, we referred to as surf poisoning. We had a state that we literally could not eliminate from console without a hard shutdown and delete of the cluster state, which wasn't really an option for us until like week 2 or 3. Which funny enough is that when we did do that, it actually didn't fix the problem, because we ended up right back in our as soon as we turned things back on, we would delete the state, turn it back on, and it would look great. And I'd go to bed, and 8 hours later I'd wake up and I'd be looking at this again, because there was some node out there that still had the old state. You couldn't just delete the console servers and delete the server state. You actually had to delete the state on all of the nodes in the cluster, and it's not realistic to shut down 20,000 instances and delete their state and come back online. That was not a thing. So what were we doing, or what were the impacts that people were seeing at this point? We were starting to see availability problems in our non-production environment. Our load balancer system for our platform is hyper-converged to console, right? So you don't have to define load balancing in DNS or certificates or anything. We just look at we have an opinionated pattern on how you deploy, and we give you load balancing. So our load balancers talk to console. So we had problems where the load balancers had routes for workloads that didn't exist anymore, or they had backends for IP addresses that weren't assigned to that workload anymore. So we were starting to now see impact after some time. We started seeing slow start times for applications as they would boot up, because they need to check into console to say, like, hey, I need my runtime configuration, right? And I'm going to wait for you to give it to me. And console was becoming so burdened with the load that it couldn't effectively respond to those things. And when it did respond to it, sometimes it just gave us the wrong answer, because someone would make an update to a config, and the console servers need to replicate that new config to the other console servers, and it couldn't do it in an effective amount of time. So the client workloads might have gotten us stale reads, so they'd get incorrect configuration when they came up. This was further exacerbated because our developers were taking it upon themselves to fix the problem with their apps by redeploying them. So we just keep churning more things, and it's great. I love that they have the initiative to go fix things like this. But the bigger problem that we had is because of this kind of state where, we don't know what the current state of the cluster is, and we haven't really converged, is that as they started redeploying these things, their workload that had this IP address in their not prod environment, when they redeployed it, would release that IP address, And then someone else deploys something in prod, and suddenly something in prod has that IP address from DHCP, and now our not prod cluster is trying to talk to our prod cluster to ping that node for, hey, are you there? And luckily, thankfully, by some magical means, these clusters didn't converge their states together, because we did have at least that configuration in console, right? But they were sending the messages. So the agents were picking them up, and they were processing those, having to process those messages and say, hey, I'm not part of your cluster. Why are you even talking to me? So that was great. So now not only do we have like this weird state in one environment, but we also have that environment then poking its fingers at the other environment, and starting to cause some problems over there. So there's disaster on the horizon at this point, right? Because as soon as we start affecting prod, then we're really in we're in a storm at that point. So what do we want to do at this point? Well, it's like 3 weeks in, maybe 4 weeks at this point. I don't know. It all kind of blurs together. And we're thinking, you know what? Console's our problem. Let's just get rid of console, and all our problems are going to go away. Yeah, I'm not sure if that's going to be successful or not. But what we did know is we needed, one is because of our opinionated form of the platform, we didn't need the capabilities that Surf was giving us. We didn't need the gossip, right? We needed console service data. We needed instance health data in order to drive the load balancers. And we needed workloads to be able to get like a KV. But most of our developers weren't doing any of the more advanced console things. And we definitely weren't like sending event messages through Surf throughout the cluster and things like that. So we had an option here. So late one night, well, half the team was in India visiting our people out there, we decided, you know what, we're just going to get rid of this, right? So we actually wrote a replacement for the console agent that provided the same API, but didn't have any Surf in it. So we just wanted to eliminate this broadcast storm that was occurring. So, we buckled in, and over a few hours, days, weeks, whatever it was, we wrote this new thing and started deploying it out to an environment, and slowly started bringing that down. It also helped because we could understand the message flow better, right? We didn't write console. We can read console code, but we didn't write it, and we can only know so much about it at that point. So something that we wrote in-house, we could have a little bit better grasp of how it was working at this scale. So, month 2, when we get into this. So we got our up agent out there, what we call up agent. We got it out there. We got Surf out of the environment. Things were again back into this stable, degraded state. But we would still, from time to time, see things like this in our console metrics, where everything was working fine, and then suddenly we get a little worse, and a little worse, and a little worse, and a little worse, and then we're like, oh crap, devs are going to start complaining, and we'd have to do everything, which our first thing was, we'll just reboot it at the end of this. So we were in that mode for a little bit of time of just every morning, we're going to reboot the console cluster, and everything will be fine for a day until we can so we can get some sleep, and then maybe we'll figure this out tomorrow. So we then started doing even more things. We put some proxies in front of our console so that we could black hole some of the requests and reduce the load, and all sorts of things. And we finally got ourselves to a really happy place. And then month 3 or so, we started having this problem again. This little graph started reappearing one day. So I was like, this is really weird. This hasn't been happening for days. What do we do? So we were trying to compare our not prod cluster to our prod cluster. And we were digging through metrics. And there was a metric that we had in our metric system that we had from our not prod cluster, but we didn't have it in our prod one. Like, that's really weird. So we're like, this looks interesting, we want to compare it. So we looked at the console configs, and there was a discrepancy between the telemetry settings between the two clusters. So, of course, we updated the working cluster to match the not working cluster, and redeployed. And thankfully, this started happening immediately. In about 10 minutes after deploying that change, our prod cluster started exhibiting this problem. And I say thankfully because if this was any longer, if this was an hour or 2 hours down the road, there's no way we would have associated the change in the telemetry settings in console to this problem happening. We would have immediately assumed, at this point in time, we thought that it was client workloads doing things against console that was causing our problem. We were super confident in that, and we were super wrong. So we just happened upon this answer. So we rolled that change back, and then went to our not prod cluster and rolled the change back, and everything got happy. And I started hating myself because I was like, that was like 3 months that was caused by a change that I had introduced on about days 0 and 10 minutes in this problem. So there's a lot of learnings here on this. So end of the story is that we finally got it back to a place where it's healthy. And how did we address this, like as a team, right? So when we initially started having this problem, we went into immediate firefighting mode, right? It was what's the symptom, fix the problem, right? Like whatever it needs to be do, get it working, right? We don't want to impact our customers. And once we got past that, we were trying to understand, both why did it happen, and why is it still kind of continuing to happen, even though we've fixed the underlying problem that we thought caused it. And retrospectively, the worst thing here is that we didn't have the insight that we needed, because we weren't ever looking for this problem in a distributed system. We'd never seen it before. And so we didn't have a baseline for what was normal. We didn't know, we weren't looking at how many requests all of our clients inside of our environment were doing to console, because it had never been a problem for us before. So once we got into this state and we're like, well, maybe it's client workloads doing this, we're like, well, there's 10,000 TPS, requests per second happening. Is that normal? Is that not normal? Did that change? We had no idea, right? We had no baseline. So we couldn't have a comparison. The only thing that we could compare against was our production environment. But we couldn't see trend, right? We couldn't see what had happened over time leading up to this change. How did we tackle it in the weeks, right? We started looking at what is the complexity in the system and where can we reduce some of that complexity so that we can have a better handle on things, right? Really complex software, when you run it at scale, it's not linear, right? When you start running at scale, you're talking about orders of magnitude more complex, right? And you're talking about interactions that will happen at 10,000, 50,000, 100,000, million, instance type stuff that you're never going to see in your lab environment running 10 servers, right? And you probably won't be able to foresee it. So I really hope everyone's listening real closely. If you ever want to try and do this, like reference this as like hey, maybe surf isn't the best thing, or let's at least have measurements for some of this stuff. The other thing that you need to do when you're building a distributed system at scale is that you need to have levers that you can pull, right? You need to be able to turn things off. You need to be able to isolate, and you need to be able to isolate at scale, right? You need to be able to do that in a way that you know that you're going to put yourself in a degraded state potentially, but at least it's a known degraded state. So you can start eliminating problems along the way. And then in the months, what were we really doing? Well, it was kind of split. We were split between just trying to maintain that stable, degraded state for our developers because we had caused a lot of impact for them and we wanted to start getting some of that trust back. But then we also needed to start making these small, precise changes in the system and then observe their impact over time. There's the idea of like Lean and Six Sigma and things like that, and one of the examples they always talk about is like when you turn the dial and you watch how it changes, and then you're like, oh, that's not right, so I turn the dial back the other way, and it moves some more, and you just keep turning the dial, right? And eventually you get behavior that you don't know, right? So make your change, make it small and precise, and then watch it right? Like, let it burn in and see where it stabilizes out at, and don't try to keep responding to that. And then finally, you just have to like clumsily happen upon the answer to all your problems randomly one day and fix the world. So lessons, don't be satisfied with what you have, right? Like the technologies that we have out there, they are fantastic. They're really good at their job. Their industry has tons of experience with doing these things, and it's great to run them, right? Because we contribute back. But if they, for some reason, don't work for you, don't shy away from reinventing that or tweaking them or doing things. When you're running at scale, think about these new failure modes that might occur, right? Like get outside input in and think about, what is really the worst case, right? Even if you've never seen it before, it doesn't mean it can't happen. Build in your kill switches, build in your levers, make sure that you can control the system or direct its flow in a way that you want. If you're building a complex system, you can simplify it by making some opinions up front, right? And you can build that system to make those opinions mutatable or flexible so that you can change them over time. But having the opinion will at least give you some type of structure to work from. And then finally, have your insights, right? Put the metrics. Look at everything that you can, right? If you can track everything, if you can record everything, that's great. If you can't, that's good too, right? But you need to know how your system runs at scale, and you need to be able to see it over time, trend over time. With that, again, I was very happy to be in front of you. I hope that this was interesting for you all. My name's John Engelman. I'm going to be hanging out at the Target table. If you want to talk about TAP or this problem or any of the other exciting things that we're doing at Target, I'd love to hear from you. Please stop by. Thank you for your attention.